Hello, class. So now that we have learned how to find the circumcenter and the centroid, we are going to use them to solve problems. So the general rule is that if you're trying to find something that is the most convenient location for people, or it just comes out and said the equidistant point, you want to use the circumcenter, okay? So points that are on a perpendicular bisector are equal distance from the other 2 points, and the circumcenter represents the one place where they are the same from all 3 coordinates in a triangle. If it ever asks for the center of mass or the point of balance, that would be the centroid. So our first question has a resort with 3 different cottages. And so you can imagine a grid being just like laid over the map of, a cottage resort or whatever, and that the 3 different cottages would end up at these 3 coordinates. Obviously, in the real world, things aren't going to be quite as pretty and exact, but we use these numbers again just so you have practice coming up with solutions to similar problems. So where should they put a tennis court that is equally convenient? So we are doing some assumption here. We're assuming that equally convenient means equidistant. So the same distance from all 3 cabins. So therefore, we want the circumcenter. So that is the point of intersection of the perpendicular bisectors. So we need to find 2 of the equations of the perpendicular bisectors and find where they intersect. So I'm going to do AB and BC. So it's really important here that you keep your work organized. Okay, so we're going to start with perpendicular bisector of AB. So I'm just going to say that and put a thing there. So the first step is to find the midpoint of AB. So that is going to be 6, 4. So again, you can kind of do that in your head, or you can actually show the calculation. I'm not, we learned about how to find midpoint in the last chapter. So if you can do it quickly, then I don't need to see your calculations. Okay, and that looks right. Again, can't stress it enough that we need a visual check. Okay, so now we need to find out the slope of that perpendicular bisector, which will be perpendicular to AB. So the slope of AB is 6 minus 2, which is 4, over 10 minus 2, which is 8. So therefore, it is a half. So therefore, the slope of the perpendicular is equal to -2. So this allows me to draw a good line because I can go down 2 over 1 or up 2, left 1. I can do that again just so that it's a bit more accurate. So it actually does go through that, which is fine. Okay. And you can see that, yes, that absolutely does look perpendicular. Okay, so now we need to find the y-intercept, which we can see is going to be quite a high positive y value. So we say y equals mx plus b using the point that's on the line. So 4 equals 6. Sorry, that's x. It should be -2. -2 times 6 plus b. So 4 equals -12 plus b. So b is equal to 16. So my equation is y equals -2x plus 16. And that positive 16 makes sense because my y-intercept is way the heck up there, so that looks right. Okay, so I'm just going to kind of leave that off in its own little section. Now I'm going to do the perpendicular bisector of BC. Okay, I could have chosen AC, but I just chose BC for whatever reason, doesn't matter. So now you can find the midpoint of BC, which is equal to 7, 7. So that's where it is. That looks right. Okay, so now we need to find the slope of the perpendicular bisector by first finding the slope of BC. So 6 minus 8 is -2, and 10 minus 4 is 6. So we end up with negative a third. So that looks right for this line. So therefore the slope of the perpendicular is positive 3. So down 3 over 1. Oh, it looks like we actually found our circumcenter since it's the same point there. But we still have to verify it and keep going. Okay, so then the y-intercept is going to be some really low negative number. We can see if the green line continues. So let's find it. So our y, 7, equals m, 3, x, 7, plus b. So 7 equals 21 plus b. So b is equal to negative 14. So the equation of this line is y equals 3x minus 14. Okay, so now we simply need to find the point of intersection, which we will do. So I'll just write here POI just to keep organized. So minus 2x plus 16 equals 3x minus 14. So we put the x's together and what did I do wrong there? Always great when your teacher makes a mistake on the video. Oh, negative 14 minus 16. I was thinking we're good. I was messing it up there. Okay, so divide by negative 5 and you get x equals 6. That's what I wanted. We're good. We're good. We're good. So then our y, you put that in and you get 4. You can put it into either equation. So 6, 4 is our circumcenter, which is right there. So now you can write a sentence. Therefore, assuming that the most convenient place for all residents is the point that is equally distant, then the tennis court should be located at 6, 4. All right, our next question is a centroid question. It says on a design plan, the vertices of a thin triangular component are given, and I graphed them. Find the center of mass. Okay, now I know that the center of mass, the centroid, is a pretty simple calculation, but I do expect you to use a diagram to verify and actually draw the medians. Okay, and you will be required on your test to do that. So I'm just taking the x values and adding them together and dividing by 3 since there are 3 of them. And then I'm taking the y values and dividing them by 3 to find the average of each. So our x-coordinate is actually 0, and this is 4/3. So leave it as a fraction if that happens. So 0, 4/3. Okay, so let's do this by actually just drawing 2 of the medians. So you don't have to show me the work of how you find the midpoint if you can do it in your head. 6 minus 2 is 4. 4 divided by 2 is 2. 4 plus 2 is 6. 6 divided by 2 is 3. So there's our midpoint there. So 2, 3, and we connect it to the vertex. And then we can do the midpoint here of CB. So 6 minus 4 is 2, divided by 1 is 1. And negative, so this should be 1, 0. So obviously my graph wasn't super awesome there, but we all know I'm not great on this thing. So there you go. So I can say that the midpoint of BC is 1, 0. And so you can then verify, in fact, that where they intersect is 0, 4/3. And if you're doing this on graph paper where you're using a ruler and taking more care, it will look pretty exact. Okay, guys, so that's pretty much the whole lesson today. We are just taking what we learned and using it now within context instead of just on its own. So thanks for watching. I hope you learned lots.